Hello, this is Group 6, and our topic is lung cancer detection using MRI images. This is Shobo Zhang, and here I would like to give a brief presentation about our project. The other two team members are Yu Chen and Ming Liu. Basically, my presentation includes 6 parts. At first, I will talk about our introduction and motivation. Then I will go into details about our data pre-processing. Then comes to the module selection. In this part, I will discuss about the basic of CNN and our configuration. The next part is our platform setup. And the last part is about the result and the analysis. Moreover, future work will be introduced. Okay, the first part is introduction and motivation. As we all know, lung cancer is a big trouble in healthcare. It strikes more than 200,000 people in the United States every year. Definitely, this is a huge cost, and it accounts for $12 billion of U.S. government. From literature review, we found that 20% of lung cancer death could be reduced with early detection. Therefore, it is of critical importance to find a way to detect lung cancer in an early stage with high accuracy. Then, I will discuss about the details of our project. Let's start from data exploration and pre-processing. The data is from Kaggle Computation, the Data Science Board 2017. We download more than 1,300 patient CR images, of which each image contains a variable number of slides. The total size is 150 gigabytes, which is a big challenge to analyze and predict. So, how do we deal with such a huge size of data? Firstly, we read the scan files and calculate the thickness of each slide. Then we transform the unit into a standard CT image unit. One problem is that each patient has different number of slices and different pixel size. So we compress the data into a smaller number of slices and use the interpolation method to have an isotropic resolution. To extract the most related data, we do a lung segmentation to extract the lung part out of body skeleton and air. Finally, we do normalization and zero centering into the data. Right now, we have the most useful and related data to analyze it. To give a more direct sense of our data, we plot the raw data and the processed data. As is shown in the slide, the left part is the 3D plot of the raw data scan. The right one is the image after processing. It is clear that the lung part has been extracted, so we have less noise and outlier. Here comes the module selection. Let's first introduce the CNN. The basic structure of CNN contains convolution layer, polling layer, and activation layer. For the activation layer, we normally use the rectified linear unit function as it converts fast. The most advantage of CNN comparing to normal neural network is that it can extract the main feature so that it can have a satisfying prediction accuracy. From now, we have our module and the process data. We could conduct our experiment. Initially, we launched a data science virtual machine on Azure and did a data processing of sample data. It works but requires long time to compute. To speed up our experiment, we set up a NC6 instance which has a NVIDIA K80 GPU and can run 200% faster than the SVM. At last, I would like to show the result and do a basic analysis about our observation of the result. At first, we want to tune the hyperparameter of our CNN module. So we use 5 different number of hidden layers of CNN module. From the picture, we can see that the performance improved with more number of hidden layers, and the module with 6 layers performed the best and can achieve the 0.6 log loss. Then, we try different data compressing methods. As mentioned in the data pre-processing part, we compress the data into a smaller number of slices. Here, we increase the number of slices and found that the performance increased obviously. As shown in the figure, When the layer increases from 5 to 6, the log loss decreases slightly. However, when the slice number increases from 20 to 30, the log loss decreases obviously. This is reasonable because with more slices, we have less loss of information to give a better prediction. For the lack of computing resources, we could not increase the number of slices more. So finally, we choose the CNN with 6 hidden layers and resize the data into 64 times 64 times 30 size. And the final prediction result is shown in this slide. We train the CNN using all Sichuan data and test the prediction result with around 200 unlabeled patients. We obtain 74.7% accuracy. The log loss is 0.572, which approximately ranks 66 out of nearly 2,000 teams in Kaggle leaderboard. Although the result is satisfying, we can improve that through several ways. For example, if we have more computing resource, we could reset the image to a larger size, or optimize the long segmentation method by using neural network to extract the long part. Besides, we could use more complex and sophisticated CNN module like Google Nights or UNet. Okay, that's the presentation. Thank you.